Hi, I'm Jackson Priest.
Hi, I'm Joshua Burnett.
Hi, I'm Felicity Snelly.
Hi, I'm Jonathan Howard.
And we're here to talk to you about clean drinking water. How many people lack clean drinking water, and how does this impact them? According to the World Health Organization, globally, at least 1.8 billion people are drinking water that has been contaminated with fecal matter. In low and middle income countries, 38% of healthcare facilities lack improved water sources and 19% do not have improved sanitation. 35% lack clean water and soap for hand washing. Contaminated water and poor sanitation are linked to the transmission of diseases such as cholera, diarrhea, dysentery, hepatitis A, typhoid, and polio. This means in those countries which do not have the ability to clean and wash themselves, they are in greater risk of contracting these diseases.
What are some common types of water contaminants? Some contaminants are obvious, while others can be much harder to detect. Water may be clear, yet still be infected with microorganisms which will kill you. Some common contaminants include salt, and as we learned in class, salt can and will make your cells explode. Poop, it's obvious. Drinking poop isn't nice. E. coli is transmitted through fecal matter. Heavy metals and toxins. Things like lead, mercury, and arsenic are also common water contaminants. Other chemical contaminants, such as sulfuric acid, sodium compounds, and other such compounds, are contaminants from the industry.
It is true that the water that flows out of the taps in the majority of the country is now safe and clean. However, there is still cause to be worried. Here are some eye-opening facts. As per a 2012 United Nations study, 11% of the global population, that's 783 million people, as yet don't have an access to potable water. Owing to the fact that people utilize water for activities such as washing and waste disposal and irrigating crops, it is easy for sources of water near human population to get contaminated. By 2025, there will be a major shortage of water, clean water, in places such as Africa, India, China, and the Middle East. But those won't be the only places affected. Let's watch a video about our own waterways here in the U.S.
Before the Clean Water Act was passed in 1972, we were experiencing a water crisis in the United States. Burning water, dead fish, people getting sick. There is a desperate need for a federal law that could really help to protect water quality. Water pollution can cause a lot of negative health impacts. Drinking contaminated water can lead to gastrointestinal illness. Swimmers can experience ear infections or rashes, and rivers and lakes sometimes experience algae blooms that leave the water virtually unusable. Since the Clean Water Act was passed, many people assume that water pollution is no longer an issue. But water pollution is still a big problem. In part, that is because there are gaps in the way that the laws are enforced, and also because many of our waterways aren't adequately protected under the original law.
The principal weakness in the Clean Water Act is that it does not do a very good job of controlling industrialized agriculture. These facilities have pesticides, fertilizer, manure that can run off and cause threats to public health and the environment.
Another important source of water pollution is urban runoff, the toxic brew of chemicals and waste and other pollutants that flows through our streets every time it rains or due to urban irrigation or industrial use of water.
A lot of folks feel that the work of the Clean Water Act is done. In truth, there are over 40,000 water bodies around the country that don't meet standards for things like swimming or fishing or drinking water supply.
In addition to our existing water pollution problems, some members of Congress actually want to weaken the law, and they will, unless enough Americans stand up and say, we want clean water for ourselves, for our children, and for future generations.
What's the solution? Water purification. Water purification is the process of removing undesirable chemicals, biological contaminants, suspended solids, and gases from contaminated water. The goal is to produce water fit for a specific purpose. Also, the methods used include physical processes such as filtration, sedimentation, distillation, and the biological process slow sand filters or biologically active carbon. The chemical process such as fluxylation and chlorination, and use the electromagnetic radiation such as ultraviolet light. Also, the SE200 community chlorine maker mixes salt, water, and electricity from a 12-volt battery to quickly create a chlorine solution that can purify 55 gallons of water. And here's a video of water purification.
Piped water from the waterworks, for those lucky enough to have it, originally comes from rivers, lakes, reservoirs, or underground aquifers. The grill will stop large floating objects, fish, etc., from entering the waterworks. Next, coagulants such as alum are added, which causes tiny particles in the water to cluster in lumps, which then settle in the sedimentation process. The filter is made of fine sand to capture any particles that are left. Finally, chlorine is added to kill any bacteria. If the water does not naturally contain fluoride ions, they are often added as sodium fluoride as an aid to building strong teeth in those that drink the water.
Let's talk about some new advancements in the world of water purification. The water purification device called the Slingshot was developed by Dean Kamen. This device is powered by a Stirling engine running on combustible fuel sources. The Slingshot claims to create clean drinking water from any nearby source, be that sewage, seawater, chemical waste, however dirty, it doesn't matter. And it does this by way of vapor compression distillation. It can work using cow dung as a fuel and does not need any filters. The name of this purification device comes from the slingshot that David used to defeat Goliath. A single slingshot has the ability to purify over 250,000 liters of water each year, and that's adequate to satisfy the need of approximately 300 people. Thus, this invention has the potential to give millions of people access to clean drinking water.
Just as power will be generated locally, so will clean water. At least this is the vision of legendary inventor Dean Kamen.
Today, more than 1 billion people have a crisis every day trying to find clean water to drink.
We're all going to have to deal with the fact that water is not free, it's not infinite in its availability.
In 30 years, a gallon of clean water will cost more than a gallon of oil.
In fact, only 3% of all the water on Earth is fresh water. So in the future, it may be water, not oil, that will drag nations into war. Unless someone is smart enough to turn something polluted into something pure.
Our goal was to create a small, portable machine that could be placed anywhere and at point of use create clean, reliable drinking water from any source.
Dean Kamen believes he can turn anything wet into drinkable water. Anything. Ocean water, sludge, even sewage. Using a device he calls the Slingshot.
A simple box with 2 hoses on it, one that goes into anything that looks wet. Out of the other one comes pure drinking water that's safe. Water goes into the Slingshot where it gets literally boiled to the point that it not just boils as you watch it on a stove, it turns completely into vapor, into steam.
Recondense that steam and you get pure distilled water, no matter how polluted the source water was.
If the water coming in has metals or other kinds of inorganic toxins in it, they don't vaporize.
Until now, no one's been able to create this effect in a portable machine because of the vast amount of energy the distillation process takes. The secret of the Slingshot is that it uses a closed loop of energy. Once the first batch of water is vaporized and recondensed, all that energy is preserved in a sealed heat exchange system. The result? A machine that runs on less power than a toaster oven, and about 2% of the power required by other water purifying systems.
We can take any bad water and turn it into pure water, and we can do it with a machine this size and an amount of electricity that runs half of a handheld hairdryer, and that's a big deal.
and each will be manufactured for under $2,000.
This machine was designed to make 1,000 liters of water a day, enough for a village of 100 people.
5,000 children die every day from dirty water. Dean Kamen sees a future where that number is ancient history.
In 30 years, the world will hopefully have access to more reasonable and more secure ways to give everybody those basic needs of water and power.
Thank you for watching our lecture. We hope you learned something.